Oh, thank you. All right, we're gonna have John Mark helping me out as well. That's one thing I was gonna ask about. Manizales, Colombia. Welcome everybody. So my name is Joey Vega. So you're gonna see that on my screen it says Jose L. Vega. So professionally, I go by both. I'm sorry for the confusion, but I'm both my identity as such. I am both Jose and Joey. Please call me Joey. We'll start there. So I am going to be your engineer for today's lesson. If you might have heard yesterday that teaching is engineering. And so, mentioning some of my criteria for this lesson, um, it's really to focus on the how, right? How we teach engineering. Part of the criteria was to really focus on tools that can be implemented in a lot of different scenarios. Some of my constraints, we're on Zoom, right? There's going to be a number of constraints around Zoom. And so we'll do our best today as participants. I'll do my best with instruction and time. This is a very complex topic. And so we're going to spend, roughly 50 minutes together today. So there's a number of constraints that we have in this sort of engineering design process. So I only mention that just because it's important to kind of reinforce those ideas. A little bit about myself briefly. Some of you were here before to hear me say a few things about myself, but I'm currently based just south of Santa Barbara, California. I'm a lifelong educator in typically secondary science from middle school to high school, a range of subjects. Most recently, I was a science coach in Medellin, Colombia at the Columbus School. I'm currently now at a boarding school in California, designing a lot of my curriculum around social emotional learning and a residential program, which is really has been a rewarding experience. So let me share my screen here before we continue. So you can see that I simplified my design here. Engineering is quite complex, so we simplified a bit. So today we're really going to be looking at some tools to support solutions for our students. Some of our guiding questions, obviously we talked about how we're going to be teaching engineering. We're going to be talking about framework that we can use in a number of lessons, challenges, or structures. I really spent a big part of my life asking, how is it that people do what they do? Anytime we're asked to do complex items or even simple things, I always wanted a step-by-step framework. And so I've really spent years trying to learn different methodologies and frameworks to be able to apply not only to science, but to instruction overall. So we're going to be exposing this group to some of those frameworks, which may or may not be familiar to you all. Other questions, so what's the process for developing potential design solutions? And how can I help my students make informed decisions and evaluate solutions? So some of the objectives connected to those guiding questions, we're going to be sharing some of those frameworks. We're going to examine a potential sequence for the beginning of the engineering design process. We won't be going through all of it, but we're going to sort of pick the first couple steps here that may be familiar. And we're really going to pick one tool to dive into a little bit. We're going to apply a systems compass to evaluate solutions really from a sustainable standpoint. But first, let's go ahead and ask everybody an anchoring question here. So we've already used the chat once. We're going to use it a number of times. I didn't mention that, yep, one of the criteria, right, for myself and for the partnership was to try to make this a little bit interactive, albeit on Zoom. I can't wait for the virtual conga line at the end of this. But first, how do we define engineering process? What words, phrases, or thoughts come to mind when you hear design process, engineering design process? What challenges? So I'm going to ask you to answer one or any of these questions here in a second. So take a few seconds to think about it. What challenges or perceived obstacles are there in this design process as we learn it? Or I'm also really interested in what was the last experience that your students faced with engineering design, or what's going to be next? What are you currently planning? So let's throw some into the chat here. Take a second to think. And how would you define engineering? What words, phrases come to mind? What challenges do you face? Time, a challenge for engineering design, time, asking questions, collaboration and solutions. Collaboration is one of the greatest skills that I value in this entire process. It's the application of science to solve problems or create technologies, defining the problem, creating a solution, design, creativity. All right, Antonio is talking about his last engineering experience, designing a bike helmet. Awesome, based on the properties. Oh, I see a little bit of biomimicry used there. The ironclad beetle's exoskeleton. Excellent, excellent. Finding solutions, building as a team. Yeah, take a look. Problem solving, calculations, analysis. Empowering students is one of the challenges. Systemic thinking, great. That's one down at the bottom by Caitlin. We're definitely going to try to do a little bit of that today with our systems tool called the Compass today. Testing possible solutions, designing a Ferris wheel. Awesome, thank you. So being able to see this, I'm going to connect some of our tools and some of what we look at to some of your thinking, to some of your needs, some of your ideas. Awesome, you can definitely see some trends and patterns and commonalities in these responses. All right, thank you for that. So we're going to be working off some assumptions. I'm going to assume that some of you all have had some time to work with NGSS a little bit, whether it's independent thinking, collaborative work. You're here now on day 2. So some assumptions that we may be working off of is that you have a conceptual understanding of the 3D framework for NGSS, right? The practices, the core ideas, the cross-cutting concepts. Some of us may still be becoming familiar with this, but these are some assumptions as we look ahead. I think one that's becoming more and more important is definitely the connection between science and engineering. And you may have seen something similar where really science is asking questions to try to understand and solve phenomena, right? Which is going to use an investigative or inquiry process. Engineering, so what this conference is about, what the partnership is really these 3 days looking at how do we design around solving problems for human needs. So that's really where our focus is going to be, even though that we know that science and engineering are intimately connected. Third one, assumption is that we are beginning to understand the engineering design standards, right? The engineering, technology, and science standards. There are 5 of them here currently. We have 3 of them. Today, we're really going to be looking at ETS 1B, developing possible solutions, and we'll briefly kind of mention these other 2 as well. So one assumption is that you are becoming familiar with these, and as well as that there's a progression by grade level. So here's an example of just K through progressing to 3 through 5. We are not looking at this. I believe yesterday, some of you all were in a session possibly with Britta and John Mark, looking specifically at the progressions. Other assumptions, you may have already chosen some curricular framework to use to implement in your curriculum, that you've adopted sort of a problem-driven design to frame the engineering design process. You've potentially anticipated and defined a lot of the details, the need-to-knows to make our students successful. You made appropriate decisions around each phase of your design process, This one here on the right is probably the first one that I ever used a number of years ago in teaching. I don't see this one as much now, but this is one where I started, and we're going to be looking at a few others as well today. Another assumption is that you've figured out where and how the key science concepts are taught, learned, and practiced with the engineering process. So here's another answer in the chat that I'd like everyone to provide. So really we have to plan with a framework. So here on the right, you see the engineering design process. I'd love for everyone to throw into the chat, what framework do you use to structure NGSS learning? It can be a tool, it can be a resource. What is out there that's helped you really try to plan for your students, plan for your lessons, plan for your engineering processes? What's available to you? What have you learned? What would you share? What are you currently trying to use? Project-based learning. I think Britta today is going to go over that as well. Paul's website, this The Wonder of Science. That's a wonderfully curated site with tons and tons of resources. Let's see. John Mark said he's used the one on the screen right now, right? From KQED, Engineering for Good. Science Buddies, thanks for the link. Links are very helpful. Providing resources to one another is very important. So if you have a link, let's use it. Teachengineering.org, awesome. The Wonder of Science Inquiry Cycle, says Thelma. Open Syed. Okay, so hopefully today you're gonna get a few more of those. So on the next slide, I think I'm gonna kind of explode my tool bag for when it comes to teaching design process in engineering. So it might look a little bit overwhelming, and I kind of did that on purpose. It's intentional. So this is kind of my explosion here. So just step back for a second, take a look to see what's on the screen. Really, when I look at this, this is years of work, of collaboration, of learning, of training, of facilitating, of practicing with K through 12 educators, with a number of content, not just science. As a science coach, I actually also use a lot of these as instructional methods in humanities, in math, in English. So on the left here, you have the gold standard essential elements from project-based learning, right? They've done some reinventing of their brand, but this is really my starting point. When I plan for my students, when I plan for educators, this is really where I start. I look at these 7 elements and I think about designing using this. What you see on the right, I use as supplements. So top right, you have the UN Sustainable Development Goals. Kind of quickly, I wish I had a polling feature here. Throw up a hand, whether, yeah, let's maybe use our features here. Throw up a hand, who's used or seen the UN's SDGs, Sustainable Development Goals? Okay, see a couple there, right? That can be very helpful in guiding students to really think about a challenging problem or question. Let's go to the second one, systems thinking, specifically from Compass Education, which is geared for educators. Raise your hand or raise a virtual hand. Who's ever seen that or heard of it? Okay, I saw about 4. Typically not as many. 5, yep. Okay, not as many with Compass. It's one of my favorites. And we're actually gonna use one of their fundamental tools today. Design thinking. Raise your hand if you have seen or used design thinking in science or in instruction. Yep. Awesome. Okay. And the last one, so I typically, before I go to the last one, I typically use systems thinking really to sustain inquiry. There's a number of ways that students can analyze problems, solutions. And so I use it to sustain inquiry, design thinking. I use in a number of ways, critique and revision, student voice and choice. And so the last one, feedback is incredibly important in a process, in a complicated and complex process like design thinking, design engineering. I use feedback protocols. Students need to know how to be able to provide feedback to one another. It's important for independence. Otherwise, the teacher is always going to be required to provide 100% of the feedback, and that's not sustainable, right? So when you really think about independence and driving student learning and student thinking, you need to embed feedback protocols. And I typically use a lot of protocols from the National School Reform faculty. Raise a hand if anybody has ever heard of that. For example, like critical friends protocols is one that's used quite often. Okay. So this is basically what my tool bag looks like in an exploded fashion, right? And this takes quite a bit of time. Now, to refocus us, I don't use a lot of these with the student view. So when I really present my students with their job, I use this, right? Which is one that John Mark said that he used as well. The engineering design process. So you have a number of steps. This isn't fully going to guide students through. You're going to have to build in multiple steps to structure action, thinking, and learning. Okay, so today we're really going to focus on the ETS standards. So defining, delimiting the engineering problems. Okay, really looking at criteria and constraints that I've already mentioned. We're going to be able to qualify those, potentially quantify those. We talk about global challenges here, developing possible solutions. So the high school progression, when evaluating solutions, it's important to take into account a range of constraints, including cost, safety, reliability, aesthetics, in order to consider social, cultural, and environmental impacts. We're going to zoom in on this one here when we use the systems compass in a few minutes. Optimizing the design solution. If we had a bit more time, we can dig into this with a couple more tools, but we will focus on ETS 1B primarily. So let's talk about sequence for a second. The first 3 steps typically may look like something what you see on the screen here. Empathy mapping is going to be a way for research to happen. It's going to be a way for students to really surface some constraints and criteria. So what that entails is field observations, interviews, surveys, traditional research, and in the end, they can map it out. And I'll show you a couple of visuals for that in a second. The second sequence here, they're going to want to define and identify the problem, maybe with a needs statement. I like to do how might we's, which also comes from project-based learning. So here at the bottom, defining a problem may sound like, how might our school create a water treatment plant so as to contribute to a healthy watershed? Okay, that's one example, which may or may not work. And the third part of the sequence is to brainstorm, right? So this is really just looking at the first part up until the solutions. So from design thinking, we learn a couple steps, which you see here, which I'll talk a little bit more about. It's a creative, collaborative way to come up with a number of ideas in a short amount of time. So I'm going to quickly fly over before we get to our tool that we're going to use today. I'm going to fly over those steps that I just kind of previewed. So I'm going to show you what it looks like. We're not going to, unfortunately, dive into it because of our time constraint. But when defining the problem, we are going to be using design thinking. So defining, delimiting an engineering problem. In order for students to truly and clearly understand the problem, they have to be able to define it. And empathy mapping is a tool that we take from design thinking that can allow us to do that. So when I think about empathy mapping and the skills and strategies needed for that, I think about this. So I'm going to play this quick clip before I ask you all a couple questions. So make sure our volume is up. Let me know if you can hear it. Thumbs up. All right, I hope my choice of video doesn't make or break my reputation here. So empathy is gonna lead us to a problem. So what's the problem there? Somebody, let's use the chat a little bit. What problem are we defining? Let me open up my chat here. Poor design, right? Evidence by not being able to open the package. So that was an observation, right? Somebody mentioned frustration. We can observe frustration. Using the correct tool, right? So there's going to be a number of insights just from one observation. Is it about the tools? Is it about the package, the accessibility? Is it about the materials? Yep, I hate that kind of packaging too. If you could ask this user, right, this person who's experiencing this problem, what question or questions might you ask about this situation, this scenario? What would you want to know about this? To really get to understand a little bit more of the problem and his experience, what could we ask, right? What do you need? What's your hurry, right? Maybe thinking about a time constraint. Do you have the right tool? Right? What is the content inside? Great. So empathy really starts with observation. It continues with interviews around a scenario, problem, a situation. We continue with surveys, right? I could ask you, if we had to send out a survey about packaging to really better this scenario and better this situation for better design, what would be on that survey, right? We could do that as well. So I've mentioned some of the methods for empathy mapping. It does include traditional research at this stage, right? So when we have students try to dig into a problem, we want to get them out observing in the field, conducting interviews, right? Asking why, conducting surveys, and being able to map. So let me show you one type of a map. Okay, so this is a canvas created on Google Docs. If we were in person, we'd be looking at some low-tech options as well. These are just some stickies here for people to edit. So this is really asking, what does your user, right, the person experiencing the problem, what do they say, what do they think, what do they feel, what do they do? When we look at some scenarios, so here we had some students looking at some organophosphate pesticides, okay? We also need to mention that there are different stakeholders that are interviewed, that are observed, so not just one type, but we're gonna have a number of people involved. So here, the farmers are misusing the organophosphate pesticide. You see some may feel attacked. There might be blame involved, right? When we look at actions, create a line of protective gear. This is really just a way for students to bring together some of their research to be able to think about how to define the problem. So here's another expanded view of it. This one really just includes some of the surveys and some of the data collected, right? So when we think about our students and data and analysis that some of you mentioned early on, we can add it to this canvas. And if this was in a different format, it wouldn't look sort of as busy. But this is one way to empathy map around engineering design problems. So the second step would be to define the solution. This can have can kind of look like a Mad Lib, to be honest, which would end in a how might we. So students find underlying needs and identify the same in a question or in a statement. So how might the school redesign their purchasing practices? This is my favorite part, so as to decrease their environmental impact. The students can choose the focus after this so as to part, and that could really direct and guide their solutions and their ideas. So in the second one, how might we create city, how might our city create healthier public transportation so as to improve the health of its citizens and enhance convenience? So here, these students would really focus on health and convenience. So this can really guide, these need statements can really guide solutions. And the last step here in the flyover before we get to our tool is really brainstorming. One of my favorite protocols or practices is brainstorming from design thinking. It's very simple. You just take a mixed group of folks. You have them individually brainstorm for a few minutes first, and then you have them brainstorm as a group. It's called a build on brainstorm. So each person shares their favorite idea with the group, and the group builds on that idea. And they defer judgment. They never say that won't work, we can't do that. That same person is then going to share their wildest idea, because we want to encourage wild ideas as well. And the group is again going to build on that versus saying that it won't work. We do that a number of times, and we encourage we encourage quantity over quality at first, and then we refine that as we're able to choose and refine what ideas might actually work. So this is a collaborative and creative process that really I have found works for generating solutions with students in a number of scenarios. So we've already looked at some of these. We're going to be focusing on ETS 1B, developing possible solutions. So when evaluating solutions, it's important to take in a number of considerations, which we see here. Some content with life sciences and earth sciences that I pulled out here are the following, right? LS27, some of you may be familiar with some of these. Sorry for the middle school folks, I have high school here. So you evaluate or refine a technological solution that reduces impacts on human activities or natural systems. These performance expectations are going to give us a number of options with our students. So the tool that we're going to be using together, we're going to be participating in a breakout room in a second around a systems tool called the Compass. But first, we're going to imagine a scenario. okay? So this is gonna be the context for our breakout rooms. Let's imagine that we're asked to engineer a more sustainable school in a bio class. Students, after extensive empathy mapping and research about various environmental impacts at school, such as food waste, energy management, waste and water management, they decide that air pollution was the largest contributor that they wanted to target. They calculated how many metric tons of carbon dioxide released in the air every year from transportation needs and other factors. So this group went through the design process and came up with a solution. After ideation, their solution was to redesign the flow of the parking lot to reduce idling among cars and buses. And they also wanted to enforce a new set of carpooling guidelines. Okay, let's let that sink in for a second. So we're imagining they were challenged to come up with a solution to a problem. They created a focus. They found a solution. What I'm going to ask of you all is to actually use the compass. So this is systems compass. It helps us really analyze complex issues by categorizing an issue in 4 different ways, right? We have nature, which includes environment, natural resources, ecosystems, climate. You're going to have access to a more comprehensive list right down here in a second. You also have the link in the chat, and we can put it in there in a little bit for you to access these slides because you'll need to do that. So you can see the structure just along the lines of a compass. East stands for economy. It's the production, the consumption, the employment, the investment related to any problem or solution. Societal category, so government, policy, culture, institutional knowledge or policy, social concerns. And finally, we have well-being, and which is really regarded a little bit more along the individual aspects of health, families, how does it impact self-development, mental health, quality of life, okay? So we have that student problem and the student solution. We have a systems compass that's going to be used to analyze a complex issue. And we have 4 different categories where it provides sort of a sustainable format. So what I'm going to ask is that in small groups, and we're going to have 10 groups total, and John Mark is going to help us with the breakout rooms in a second. You're going to evaluate the student solution, right? Which was around contribution to air pollution using the compass. What you're logistically going to do is add as many benefits of the solution, constraints of the solution, and questions that you may have around the solution on here in a breakout room. So let's actually kind of do a few seconds of this together. So here is that extended view that I talked about. If you're a little bit unclear about what economy is, what well-being or what society is, here's a little bit more of a detailed view. So here's what you all are going to do in breakout rooms. So we have the solution. Will somebody provide me what's a benefit of the solution that the students came up with that I can plot or chart onto this? What's a benefit of the solution? You can choose nature, well-being, society, economy. Would somebody maybe give me 1 or 2 to plot on here as an example of what you're going to be asked to do?
Idling time, we're having a benefit for nature and less carbon emissions, reducing carbon emissions.
Thank you. Right, so you're going to try to categorize it. The goal is not really to have the right benefit in the correct category. You will think about that, but it's really thinking about how to evaluate a solution using different markers, and you can add benefits, constraints, things that may have to be answered before you may know a little bit more. So I'm gonna stop there. I'm gonna ask John Mark to set us into breakout rooms in a second. Can I answer any clarifying questions that you may have before you go into your group? You're gonna need the link to this to the slide deck, the group of your breakout number is going to be associated with the slides, and the slides are numbered in the bottom right. They're numbered 1 through 10. So if you're in breakout room 1, you're going to be finding that slide 1, and you and your group are going to be editing and adding benefits, constraints, and questions. Okay. Before we go into breakout rooms, can I answer any clarifying questions? We need to resend the link. Yep. Okay, thanks, John Mark. Okay, let's see. All right, can I answer any other clarifying questions before we begin? All right, John Mark, can we open up these breakout rooms?
Hey Joey, I think I made a mistake. This is my fault. On those slides, I changed it to view only, but I think you had it as edit. Can you? I can't change it back though. Can you change it back? I'm sorry about that.
Yeah, it's okay. And I know that's kind of funky because of normally we do it for this reason. Britta said not to use like Jamboard or anything like that. So
Gotcha.
that's why I was like, I'll close the editing right after we do this.
I'm so sorry about that.
No, it's okay. I just opened it. So as long as they try again, we'll be able to work it out. All right, John Mark. As a participant, give me some thoughts, some feedback, because it's a lot. You know, it's a lot of information. And
Yeah. Give me 1 second. I'm just quick.
Mm-hmm.
Doing one thing. 1 second. Sorry. All right. It's been really good so far. Like definitely awesome use of tools. Yeah, I feel like the empathy mapping was it was all really good. I was at first you started out a little bit slow, and I was like, oh man, is he going to make it to the breakout room? But I feel like you're doing great on time.
Yeah, and part of me is doing that. I looked over at one point, and then I was like, time, and then I picked it up.
Yeah, yeah. I feel like the first part, like the only thing I'd say is maybe like the whole like raise your hand if you've used this tool. Maybe like not necessary. You could skip over that, but other than that, it feels like time is good so far.
Great. Yeah, that's what I need to know. I mean,
Someone in room 7 is asking for help. Can I stick you in room 7?
Yeah, I'm actually there right now. Let me join.
All right, go ahead. Cool.
Okay. Okay. Yeah, it was definitely just the access to the slide or to the slides. Okay, first part was slow. Yeah, I was just gonna ask you, what were the slower parts that I could easily move on?
Yeah, I think the. Let me go back up a second in the presentation.
The assumptions.
I thought the assumptions were great. So I feel like at first I saw that slide and I thought you were gonna go into like the ETS standards and the progression and stuff, and I was like, oh no, we did that yesterday, but you obviously knew that. So I thought it was really great.
Yeah, I wanted to be
Say
redundant.
slide 7 and 8.
Mhm.
I feel like you could not necessarily have the interactive part of those slides, like as opposed, so you can just kind of get into the like tools you're providing.
Say it again. Get into the what?
So like I'm saying for slide 7 and 8, as opposed to having people answer in the chat and or raise their hand if they've used any of those tools, I'd say you could maybe skip over that just so that you can get going with like the meat of the presentation,
Yeah.
which is obviously the tools that you're providing.
Great.
Maybe it might be useful. Hold on 1 second, sorry. Maybe at some point it might be useful also to pause after you presented those tools around empathy mapping and around the how might we question and the protocol for generating solutions, and pause to see if people have like questions.
So I actually meant to, and I totally didn't because I didn't build it into the slides, and so I totally meant to ask around thoughts for each of those three.
Yeah, I think that would be useful. Like for me, I definitely had one question that I wanted to ask.
Yeah.
And that is my question was around the user. Like, and that's, do you select the user? What point in the process is the user selected? Is that something the teacher always selects?
Not necessarily. It's really who is the problem impacting, right? And there's some options there, but yeah, no, I think, I mean, that we want that to be student generated because that's going to guide what they do.
Yeah,
Lower
but it
grade
definitely
level.
but the user has to be chosen at the very beginning of the project, right? You can't like, because that's important for the empathy mapping, right?
Yeah, except with empathy mapping, like we also want, it doesn't have to be so specified to like students, but it could be like a population or a community, because within the empathy mapping, you'll have those that are making policy
I'm sorry,
potentially.
I was kicked out. I was in group 4.
Awesome. I will stick you back in there. There you go. And Lucia, do you need to get back into a breakout room?
Hi, sorry, I'm just logging in, so I don't have any group.
Awesome. I'll stick you in a breakout room for now. They're going to be in there for like 2 more minutes. Just
Okay.
kind of see the activity they're doing.
Okay, thanks.
Yep. But in 10 minutes is up in 2 minutes. Do you remember, are you ending at 5:50 or 55?
50.
Okay.
Let's end it. Yeah, it'll be a quick wrap up. I have a reflection that we can answer together as a whole group. And
Cool. I think 55 is fine, just so you know. Yesterday, all of our sessions ended at 55. I think for some reason we changed it today. So.
Okay. All right.
Yeah, just let me know when you want me to close. And just so you know too, like during the end of conference survey, people will have opportunities to like give you direct feedback on the presentation, but they'll get that tomorrow, just so you know.
Yeah.
All right, let me know when you want me to close them. It's been like 9 minutes.
Okay. Will you give them like a broadcast warning?
Sure.
Be like, we'll close in a minute.
I think it's been really good. I feel like I'm like super curious. I would love to be in these breakout rooms actually to hear the conversations they're having if like people are using this or how they're applying it in their context. Because I feel like it is like these are super helpful tools. Like I just did an engineering design project with my high school biology kids, and I wish I'd had the empathy mapping, see, think, whatever, say thing. Like
Yeah.
that, super helpful with what they were doing.
I mean, each of these pieces are like, especially the compass, can be multi-hour practice
Yeah.
with it. I mean, it's good sort of exposure for it, but
Totally. All right, I'll go ahead and close it. I'm not sure what the time, like how much time it's going to give them, so I'll just close it right now.
okay.
All right, it's giving them 10 seconds.
Meeting is being recorded.
Hello, everybody. Welcome back. So that was a really brief interaction with the systems compass. So let's reflect a little bit as a group. I would love to hear, how did it go? What was that like? Can somebody maybe unmute themselves just because we'll close, and I'd love to hear from some of you all. Brief interaction with peers. I got a thumbs up.
I'll share.
Yeah, please.
I thought we had a nice group. I felt like it was a really quick, easy way for everyone to throw in their ideas or throw out ideas and put, and I felt like when we heard somebody's, we could bounce off of that and go to somebody else's. And then just having all those different categories, it was kind of like everything we came up with went somewhere. So I felt like it was super open-ended. Which I think we need for kids a lot of times, because sometimes it's like, well, that's not really where I was going with that. But if you have a place to put their thoughts, I think it's very good.
Absolutely. Thanks, Gail. Morgan, is that a hand up?
Yeah, we talked about how we really liked the system compass. Many of us had never used it before. Some of us had, and she was actually just sharing at the end about how great it is, not even just in engineering, but in also other science areas, and how it really gets students thinking about different areas of the problem or the phenomenon that they're looking at. I thought it really helped us come up with questions and constraints and benefits that maybe we otherwise wouldn't have thought about without that kind of structure in place. So that was very helpful.
Absolutely. Thank you. So I'd love to hear two more things. So really, where and when are you going to use it? How are you going to use it? Can you imagine yourself using it? So maybe if somebody can tell us if they can envision themselves using it in a very specific place that's coming up, or if you'd go back and stick it somewhere. I'd also love to talk about limitations to the tool, right? I like sharing tools because we can modify them to improve them, supplement them. Do you have any other tools? So how do you want to use this? And then really, what are some limitations? What would make it more effective? So maybe answer one of those two. If somebody would.
One thing that might be, you're having the, besides the cardinal directions, you could have like the north, south, northeast, southeast, and southwest. That would be like an intersection of maybe like environment with well-being, or an intersection of economy with one of the other ones. That could be a variation, I guess.
Love it. Absolutely. Yep.
I would also like, in our group, we focused on the positive of the solution, and it suddenly someone remembered that we had other two things to talk about, the constraints, and I don't remember what the other thing was. And so maybe have something in each of the north, south, east, in each part of the compass that could show you like with different colors, so that students or us, we can remember that we have to focus on other things also.
Yes, thank you, thank you. It's one of my favorite tools. With complex systems, you have to break it down. You have to look at different components. Let's see, James, inquiry cycle solution leads to more research. Absolutely, this sustains inquiry. You should have a number of questions that pop up from this work. It's very collaborative. Somebody mentioned lots of perspectives here. I'm gonna show you one slide that gives you sort of an advanced view or just a how to level up on this a little bit. So what's also possible, so typically this is gonna be a low-tech exercise to really get hands-on. So thank you for dropping in the link to Compass Education there. Let's see, Caitlin. So I wanna show you this picture. Kind of dug this one up. So this really has a couple images to kind of anchor some of the ideas, but what you see here are students making connections and really getting to those intersections that I think Russell mentioned. They're finding those intersections, they're making connections, but at the same time, they're identifying relationships. The way that you do that is simply by adding descriptors in terms of increase or decrease, or some students would add, I would direct them to add pluses and minuses to really identify how one variable impacted another. This also can lead to like causal loops, which is another thing to explore in the future, where you can kind of isolate those variables and really look at what's driving things up and down in terms of the relationship. So there's options. This really gives you a lot of options. It's going to help you collaborate, at least interdisciplinary work, and you can get a lot of really good qualitative feedback here. I'm still wondering how we can turn this into some qualitative work as well, right? That's one question I sort of leave you all with, as we always want to analyze solutions and think about the work that we're doing and how to help our students. So really, we're gonna stop there, folks. It's 2:55 California time. So I really hope you enjoyed the compass specifically. We did a quick sort of flyover, and I know you might have a couple or a number of questions from empathy mapping, from the ideation, maybe the need statements. My contact is at the bottom of that. I'd love to collaborate and answer questions. So send me an email, and I'd love to be able to help you in any way. So folks, it's been great. John Mark, we just do a quick sign off and we're good. Awesome, folks. Great to have you here for a short amount of time.